I'm going to ask you to think this through and make it. Obviously, we're going to do this, right? So the chalk jump off the board, didn't you? Okay. This, just like what we did here, right? So, well, and we'll work it out for us for next time.
Green's theorem.
Oh,
Okay?
That's weird.
And I'll even tell you what it ends up with.
Whew.
Okay? It's just QX of
so I assume that's for all three nuggets, just this for us.
if you use the same ideas here,
I think you already have that book.
the value from here to here changes by what?
C2.
Okay, we're integrating Q over this. The value of Q changes.
Negative
Negative's a good start.
Q Y dy.
But Q's changing as you move in the X direction. So right idea, but it's QX delta X. Just like when you were doing P here, the value here is different than the value here because P changes with respect to Y, right? The difference in the values here is because Q changes with respect to X. Okay? Make sense?
Yeah.
Okay? And you don't get a negative sign when you work it out. And you just write out the symbols, just totally analogous to this. Once you get the idea that the reason the integral over this line differs from the integral over this line is because P changes with respect to Y.
What were P and Q in this?
They're functions,
Functions of.
X, Y.
Okay.
Okay?
Is that our force function? Our parametric?
It could be anything, okay? And it could easily be a force function because you might want to integrate the force around a region, right? And if you get 0 for every possible region, you know you have a conservative force. Okay? So, yeah. Good question. There are many other. Yeah, you know, it's circulation. Okay? And it's actually more applicable to like fluid flows where you can have vortices, circulation of fluid around a point, or flux of a fluid through a surface, because you can also do this as a flux integral. Okay? I don't see anything in your text that addresses flux integrals at this point, but it's a simple change, so we'll just stick with what I'm going to assign you out of your text, okay? And then we'll bring it around to flux integrals because I think it's kind of important to do that so that, because when we do this in 3 dimensions and extend this to Stokes' theorem and the divergence theorem, a lot of that has to do with flux, okay? Stokes' theorem more circulation, divergence theorem with flux, okay?